Question 9. Expand the following functions as a series of ascending powers of x up to and including the term in x3. In each case, give the range of values of x for which the expansion is valid. Yeah, we'll do the first one. 1 minus 2x to the power half. So in expanding this, you use the expansion 1 plus nx, or how do you put it? 1 plus ax to the power n, where we say 1 plus nax plus n minus 1 over 2 ax squared plus n minus 1 n minus 2 over 3 factorial ax power 3. In all application questions, the highest or the furthest you can go is power 3. So as you can see even here, they are saying expand up to and including the term in x3. So you use this formula whenever you have a 1 there, or whenever you force a 1 to be in the first position. This means that we have 1 minus 2x to the power half, giving us this means that we have 1 plus n is half, and ax is negative 2x plus half as n, half minus 1 and negative 2x squared. Now to write the 2 which is down there, okay, let me write it so they're not confused. Plus half minus 1, half minus 2 over 3 factorial is the same as 3 by 2, and then negative 2x power 3. Like that, giving us 1 minus x. And you're simplifying now, plus half minus 1 is negative half, negative 2x squared, that is positive 4x squared over 2, plus half minus 1 is negative half minus 2 is negative 3 over 2, and then this gives us negative 8 over 6. Okay, let me write it as it is so that it will be easy cancelling there. Over 3 by 2, and then x power 3 plus dot dot, giving us 1 minus x. This here gives us, or we can leave this 2 and take away this 4. So we have left this 2 and take away the 4, that is by 2 and then 4, so that we get minus x squared over 2 and then next this 3 and this 3 will go, then 1 2 3 we'll take away the 8, and then it will remain as a negative. The 1 minus x you have simplified 2 there, so that we get negative x3 over 2 again, dot dot, like that. So what does this mean? This means that you have expanded up to and including the term in x3. Okay. The next thing we do is we find the range of values for which expansion is valid. For any function, any series that you deal with, to find the range of values of x for which the expansion is valid. If your expansion is in this form, in the brackets, you put ax in the modulus and make it be less than 1. Extract a as a positive number always without leaving a negative inside, so that you have x less than 1 over a. Okay, this happens even if it was b plus ax to the power n. You just make sure that b is positive, so that you say ax is less than b, and extract a, so you get x is less than b over a. So in our case, we have the simplest case. We just get negative 2x less than 1, implying that 2x left alone there will be less than 1, so that the range of values of x for which the expansion will be valid is only for x less than half in the modulus. You know, this is an interval. From inequalities, we saw that this is the same as negative half less than x less than half. There's no harm in leaving it here. There's everything wrong in leaving it here. If you leave it here, it means that you don't know how to extract it too. That's the meaning there. So if we can do this question, it's enough to represent the whole question 9. So how to go to question 10?
Sir,
Hello.
see, solve something.
You don't like hard stuff, so who likes now?
Huh? Sir.
So, repeat the other page just for me. Okay, thank you. Okay, thank you, sir.
Okay. We put up C, 2x plus 1 over x minus 1, x plus 1. So I'll do it up somewhere where you begin to see that it becomes similar to this, and then you finish it up. Now, when you find that the power of the numerator is less than the power of the denominator in terms of x, on top we only have one x. Down we have x times x there that can give us x squared. Meaning that we need to break this into 2 partial fractions. If you have not yet done partial fractions, this is how you learn here. You learn by doing. So your next step will be 2x plus 1 is equal to a x plus 1 plus b x minus 1. And then start solving for a and b. So you notice that when x is -1, what we'll have is 2 by -1 plus 1, giving us a -1 plus 1 plus b -1 minus 1. This becomes -2 plus 1, which is -1. This is 0 here. So we'll have -2b, telling us that b is actually 1 over 2. Get back, when x is +1, what we'll have is 2 plus 1 is equal to 2a. The b part there will be 0, meaning that a is equal to 3 over 2. So you go back and substitute. So instead of expanding 2x plus 1 over x minus 1, x plus 1, you expand it in the form a is 3 over 2, 1 over x minus 1, plus b is half 1 over 1 plus x. Now we have an issue. We need to write the first one, factor out the negative so that it comes here. You have negative 3 over 2 and write this as 1 minus x. And then now it becomes okay because the other one is like that. So to expand, you have negative 3 over 2 and have an expansion of what nature? Of 1 minus x to the power negative 1. You also have plus half and expand 1 plus x to the power negative 1, each up to and including the term in x3, and then put the sum together. So we have negative 3 over 2 open 1 plus negative 1 multiplied by negative x plus negative 1 minus 1 multiplied by negative x squared over 2 plus negative 1 neg 1 minus 1 neg 1 minus 2 over 3 by 2, that is 3 factorial, and then negative x to the power 3. Close, go to the other one, plus half 1 plus neg 1 x plus neg 1 x squared over 2 plus neg 1 neg 2 x power 3 over 3 by 2. Close, meaning negative 3 over 2 and then 1 plus x. So you can see that if you went inside here, this is still negative 1, this is negative 2. So this, when you multiply, you can take away the 2 down. This is neg 1, this is neg 2, this is neg 3, and they have a negative from here. So this 3 and the 2 can take away that. The negatives are 4, so they will take care of each other. So us will just have no constant attached plus x squared and then plus x3 for the first one, plus a half and then 1 minus x. Again here we come down, so we'll have this negative 1, this negative 2. So 2 will be gone, the negatives take care of each other. This is neg 1, neg 2, neg 3. The negative will remain, but 3 and 3, 2 and 2, only the negative will survive there. So what we have? We have positive x squared and then minus x3. So your next step is to expand and add like terms. So that for now, that one can be left for you to do. So expand and add like terms. So that for now, we deal with the range of validity. The range of validity, we get the modulus of x, the modulus of negative x. For the first one, it must be less than 1. And the modulus of x must be less than 1. So you notice that we're talking about the same thing here. And the other one also is less than 1. So you just get the intersection, at the intersection, which is just one of them. This can also be written as negative 1 less than x less than 1 for range of validity. That's how we write it. Like that. So this was question 9. Question 10 and 11, 12 are similar to each other. Question 13 has already been done in question 4. Find the first 4 terms. That one is an easy thing. So between question 10, 11, and 12, choose one.
Question 12, sir.
It's the easiest.
Question 10, sir. Question 11, sir. 11.
Yeah, let's try 11.
11, sir. 11, if you cannot take your barrier.
Let's do 10. All the questions you're choosing are the easiest. Let's do 10. By substituting 0.08 in the expansion of 1 plus x to the power half, first let us have the expansion. 1 plus half x plus half minus 1 x squared over 2 plus half minus 1 minus 2 over 3 by 2 x3. So you just end at 3. So you have 1 plus half x, and this will be minus 1 over 8x squared, and then plus 1 over 16 x power 3, like that. So 1 plus x to the power half has given us this expansion. The guidance is by substituting 0.08 where there is x. So we substitute 0.08 where there is x. 1 plus half 0.08 minus 1 over 8 0.08 squared plus 1 over 16 0.08 power 3. So first we simplify here, we get 1.08. Half is the same as the square root, is equal to 1 plus 0.04 minus 1 over 8, 0.1264 plus 1 over 16. What is 64 by 8? 64 by 8, we get 2 here, carry 1. 6 by 8, that's 48.
512, sir.
512, good.
512.
So 1, 2, 3, 5, 12. So notice how I'm counting the decimals. So where we have power 3, we'll have 6 decimals. Where we have power 2, we'll have 4 decimals. Then now this is the same as on the left. This 1.08 is the same as 108 over 100 is equal to 1.04. If you add the first 2 terms, then 0.0008. That's the number of times 64 can be divided by 8. And then plus 0.123. 16 in 5, we get 0.
It enters 32 in 512, sir.
32. Okay, yeah. So it will start entering here. Since it will enter in 5116. Like that. So the question is, we must find the value of root 3 using this. So the root of 100 is known. So we can extract 100 as 10 out of the root and then do the subtraction. What is 1.04 minus 0.0008? Somebody is saying I let them in. The class is open. It's not locked.
Excuse me, sir.
Okay.
So is your square root for the numerator and the denominator, or it's only for the numerator?
It's for both.
Okay, thank you, sir.
Okay. So that 1.0 also I can get 1.04 minus 1.0. So this will be left as 391. So we get 2 there, 930.1. Then that number, so we can bring it here, 1.0392 plus 0.123432. When you add these, we get 1, 2, 3, 4.
1.0.
We get 1.039232. Okay, then we multiply through by 10 so that we have 108 alone here. That guy becomes 10.39232. An approximation now. Then we're looking for root 3. So we write 108 as 3. So you get 108 divided by 3. So you have 3 into 10, 3. Remainder 1. 3 into 18, 6. So you can write 108 as 3 by 36. Approximately 10.39232. So that the root of 36 is 6. Approximately 10.39232. Divide by 6. Divide by 6. So we get that the root of 3 is approximately 6 into 10 is 1 point. Is 1 point. The remainder is 4. It goes to 3. You have 43. 6 into 43 is 7. That one I'm sure. Yeah. Remainder 1. 6 into 19 is 3. Remainder 1. 6 into 12 is 2. Remainder nothing. How many decimal places, huh? To four significant figures, 1, 2, 3, 4. We've reached. I don't know if if the next number is bigger than 5. Let's see. 6 into 3 is 0. 6 into 32 is 5. Okay. So
3, 3, 3, 3, 3.
Punch. What's the punch? You know, and they get to punch what root 3 is.
It's 1.73 to and to 1.73 2050808.
So just leave it like that. I remember that when dividing, when you say 6 into 3, then go you put a 0. Then you bring 32. So you leave it like that. So binomial approximates exactly. So when they're making a calculator, they are using binomial to give them the values. So this answers question 11 and 12. and 13. Question 11, 12, and 13, done. So we're done with binomial. We're supposed to start calculus, which is question 14. The next class next week, we'll start calculus. Have a good day.
Thank you,
Thank you, sir.
sir.
Yes,